Hey, welcome back to my videos on analyzing COVID-19 data with SQL. And what I want to do is just set this one video aside because it's a little more abstract. And I want to look at a statistical test, specifically one called Analysis of Variance, or another way it's referred to is Anova. One of the things we learned in the last video was that there seemed to be some differences in regions. Now, when we're talking about differences, we don't mean maybe one number is slightly more than another number or another number is slightly less than another. We're saying, considering all the variability in this data, are the differences large enough where we can assume they come from two different underlying populations? So the assumption is that all the data we work with comes from the same underlying population. So you can imagine there are three different distributions here, but they're all smack dab on top of each other, so they're exactly the same. The alternate way of thinking things is that they come from different underlying populations. So the mean for one group is different from the mean from another group or another one. Now, in analysis of variance, only one of them has to be different from one another. So look at this example. I have some averages or means from three different populations, but look at how variable it is. And then we can look at this middle one and this one here on the left. Notice that the tails, or the confidence interval we're looking at, encapsulates all three of the averages or the means. Same with this one. All three of them fall inside this distribution. So what we're going to basically say is that, there's a lot of variability in terms of what happens, but generally they're statistically close. Now in this example down below, that's a different story. Here, they're so far apart, this distribution doesn't even cover the other means. So those are so different that we would say they come from different underlying populations. So what does that have to do with COVID-19? Well, just this. Like I said, we saw that there was some regional differences. The question is, are the regional differences, whether it's deaths or hospitalizations or cases, are they different enough to assume that one region of the United States has a different characteristic than another region of the United States? Now, one of the tests that we perform is a t-test where we can look at two, but an analysis of variance test looks at three or more. Now, to run an analysis of variance, what I need is the averages for the region, the number of observations in that region, and the standard deviations. And you can see here we have averages, and we also have something to do with distribution, so standard deviation. So that factors into the analysis of variance equation. So this is the next formula, or the next script or query in our list, and this is looking at analysis of variance by region. So let's take a look at what this query is actually doing. Well, before we do that, let's show you what the answer is going to be. I need to supply this online calculator in statpages.info/Anova1 SM HTML. So you can go to that yourself if you want. And I need the number of states inside the Northeast, Midwest, South, and West region. I also need the average, again for positivity, and I need the standard deviation. So here's our query. Let's start from the inside and work our way out. So our first query is we're going to take the state, the UPS symbol, right, for the state name, and the state population, and the region. Well, why don't we just do that? That's probably easier. Again, so let's run this, and you can see this query is telling me for every state what region it's in and what the population is. So this is now thought of as a table, and I'm going to call that table T1. Now I'm taking T1 and I'm comparing it with the table daily. We've been working with that daily one for quite some time, but I'm going to do it where the state in daily is equal to the state UPS code. So where Maryland is equal to Maryland, where Delaware is equal to Delaware, and so on. So inside of this, I'm going to now run this query where I'm selecting the state and the sum of the increase in positive divided by the population, and that gives me the percent positive. And again, in this case, we're going to also grab the population and the region and from the two tables where those states are similar. In fact, let's get rid of this one more time, and we'll run what this next part of the query is doing. There we go. So now I have the population and the percent positive for for each individual state. So I'm going to wrap this, of course, in other parentheses, and we'll run the next query. Let's just paste that in. So now that I have this data, I want to get the count in the region. So here's 4. Well, here's a 3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So I don't want to count them by hand. I'll use SQL to make that count. We're going to call that n. I want to get the average of all the percent positives in that area. We're going to call that the mean. And I want to get the standard deviation for the percent positives as well. Now remember, this is something that SQLite offers, standard dev _ samp. SQLite does not have a function for standard deviation. So we're going to get all of those, and of course we're going to group it by region. So I'm going to have the average for region 4, 3, 2, and 1, and the standard deviation for region 4, 3, 2, and 1, and the count for each of them. So let's run that. And these are our values. So the Northeast region is number 1, and it has 9 states in it, and this is its average for the percent positive. Remember, we can always go in here, and you can always go in here and change it for the dates. Ask what happened in July or August. So you don't have to just do it for all of the data. We also don't have to do it for percent positive. We could do it for the death increase. We could do it for hospitalization. So I'm just showing you this one for the positivity rate. So we'll go back to this page, and you can see these numbers here. So I just went in and I typed each individual one in, and I replaced where it says 1 with Northeast, 2 with Midwest, because I knew that, and this tells me the records that are in each of them. And now let's compute the analysis of variance table. And that's done. There's a lot of stuff you may not understand, but I'm going to draw your attention to this. This p-value, this is the probability that I would be wrong if I said somebody from these distributions comes from a different underlying population. So this is basically saying you got no chance of saying that. There is definitely a difference in the different data sets. Now, down below, it's telling me where that difference might be. So again, this is the probability of being wrong if the Northeast and the Midwest are different. And there's about a 40% chance of being wrong. In statistics, we like to be about 10%. The Northeast and the West, they are very similar. There's a 97% chance you'd be wrong if you said, no, those two really are different. Where do we see some differences? Well, and same with the Midwest and the West. We see a big difference in the Northeast and the South. And we also see a big difference in the South versus the West. And a bit of a difference in the Midwest versus the South. So the South has some things going on that are a bit different than the other groups. If you look at the data, you can see, oh, that kind of makes sense. The South has, a large or larger number of positivity rates based on the population. And it's double that of the Northeast and quite a bit more than the West and the Midwest. But don't forget, there's also some variability in each of these. So it's hard for us by our eyeballs to say, yeah, I think this one is different or they're different. They're just small numbers to me. But when we run a statistical test, then we can determine that there really are differences. And the differences appear to be in comparing the South with the other places throughout the country. So like I said, you can explore other kinds of statistics. The purpose of what we're doing here is just to show you that you can formulate and structure your data in a way that will feed it into a statistical analysis. Now, if you want to learn more about how to perform statistical analysis and what things like a t-test are and analysis of variance and how they relate to geography, and other kinds of social science disciplines as well as physical sciences, you can go to my website and my online courses. I have one called Statistics for GIS Professionals, so you can register for that course here. That's about a 5-hour course or 4-hour course, almost like a one-day workshop by the time you get through it. I also have one called Statistical Problem Solving in Geography that's based upon my textbook. That's 12 hours of material that takes a very deep dive into hypothesis formulation and statistical analysis. Both of these courses are under $12 so you can pick them up if you register for them here. But again, what I'm really trying to show you is if you can think of the data and formatting it in a particular way, you'll be able to use SQL to get the data prepared so that you can run more robust statistical tests. Hope you liked this video. If you did, please press like. Also consider subscribing to the channel so that you'll get more videos when they come out. And don't forget to leave a comment down below and tell me how you might be using some statistical analysis as you analyze the COVID-19 data.